these are the early stages for me of just kind of looking into things. And of course, at that point, you start questioning everything. And it goes back for me to a question that Mark asked me, and I still can't remember. I should just go back and watch the show again or listen to it. If he did it on the show or if it was a conversation we had after it. But at some point, he said, okay, Rob, I get it. You believe we live on a ball. Cool. Prove it. Without using NASA, the government, or the military of any nation. Well, that goes to what I said earlier. Why? How many of you trust the government? Believe the government's a trustworthy source for truth? Anybody? Going once, going twice, right? Well, how many of you know the military and the space programs of any nation, they answer to their governments, right? But we all do the same thing. We all say, well, we've all seen the pictures. We've all seen the pictures in the textbook. And I did that, and this next video illustrates some of the things that I found very, very early. I'm talking like within a week or so of talking with Mark, the things that started kind of messing me up.
One of the first images that I saw when I did my initial research was from this webpage right here, the Jet Propulsion Laboratory website. And this shows a video right here. And you click on that to open it, and this is what you get. And this is a very small and low-res video. And when you look at it, you're like, wow, okay, this is supposedly the Galileo space probe at 6 a.m. Pacific Standard Time on December 11th, 1990, when the spacecraft was about 1.3 million miles away from the planet. This is a time lapse representing about 25 hours of rotation. So just over a day. See, it says motion picture showing a 25-hour period of Earth's rotation. And atmospheric dynamics. I'm not really seeing any atmospheric dynamics. I see what appears to be a blue marble with clouds on it, but I don't perceive any motion in the clouds. And that's the first thing that caught my attention in the beginning of my journey. It was like, wait a minute, none of the clouds are moving. I could take my camera outside and point it at the sky for an hour and speed it up, later, and the clouds are going to be doing all kinds of stuff. But on December 11th, 1990, in 25 hours, it doesn't appear the clouds are doing anything. Now, I had to hunt around for a larger version of this, a better, higher resolution version of this. I don't remember where I found it, but I did eventually find a bigger video, higher resolution. And this is that video right here. So you can see it's HD, much crisper. I actually added a little bit of sharpening to it to make everything stand out even more. And so we'll look at it again. And so one of my questions is, were they even capable of producing an image like this and beaming it back to Earth from 1.3 million miles away back in 1990? That maybe so, I don't know, but seems suspicious to me. But again, none of the clouds appear to be moving. If you pick a region to look at, and I don't see the clouds changing at all. They seem to just be following the ball as it rotates. So that's what initially got me questioning everything. And the other thing is, if this is a space probe flying away from the Earth, how is that working in this scenario right here, where we're supposedly in a solar system with the sun racing through the universe at over 500,000 miles per hour? How is the space probe keeping up? You might say gravity is taking the space probe along for the ride, but I'm having a hard time with that. I don't really buy that argument. It's okay if you do, but I have a hard time believing that. If the solar system is whipping through the galaxy at over 500,000 miles per hour, how the heck is the Galileo space probe keeping up with everything and keeping a nice steady shot of the Earth? That just doesn't make any sense to me. Now, here is some footage allegedly shot from a Japanese space probe. Now, this moon, it looks somewhat realistic, I suppose. Wondering where the stars are. And here comes the Earth popping up here. Again, this does not look realistic to me. I'm sorry, there should be lots of stars out here. This isn't giving the appearance to me of an exposure issue, where they always say, well, the camera is cranked down so the exposure, well, actually, there's probably a way I can check that. I can adjust the brightness and the contrast. If this is HD and it claims to be HD, it supposedly is HD footage. when I adjust the brightness, there's no information on this video. There's no data in here. I should be able to see the Milky Way galaxy back there. I'm adjusting this. There's no information. That is a pitch black background. There's nothing here indicating that this is HD footage of the Earth in space. It should look more like this. So I'm going to call BS on this. Also, this is total CGI in my opinion. Now, look at this animation right here, and I'm going to call it an animation because that's what I believe it is. This is from 2011. This is supposedly a 4K video taken by the Electro L weather satellite. Notice anything different? Now, along the same lines, how is this geostationary satellite keeping a perfectly stable shot of the Earth at about 1 million miles away, enduring all the radiation that's out there, while the solar system is allegedly shooting through space at over 500,000 miles per hour? How is this keeping a perfectly stable shot of the Earth? I don't know. But looking at them both side by side, both represent a day. Notice anything different? But the only thing I'm noticing is better CGI. This represents over 20 years advancement in CGI technology. And this image here on the left proves it. This is 100% CGI and admitted to be such. It is a ball with cloud dynamics mapped on it, CGI. And I found that as a result of somebody sending me this right here, trying to pass this off as, see, Rob, the Earth's in rotation with the clouds moving, so, you can stop saying the clouds don't move. And I'm like, first of all, I'm like, if you can't tell this is CGI, I don't know what to do. I don't know, I can't really help you. But I said, I saw right here, it says the source was this website right there. So I clicked on that and that took me here to this Geophysical Fluid Dynamics Laboratory website. And if you scroll down here, the two links you want to pay attention to is the hurricanes one and this mesoscale dynamics. I'm not sure how you pronounce that. Those two links. So we'll look at the hurricanes one first. That's this page right here. And if you click on this MP4 file, it brings up this video right here, which shows a flat map with dynamic clouds doing all kinds of interesting stuff right here. But this is 100% CGI. And care to guess what might happen if you map this onto a 3D sphere? Well, you'll end up with something like what's on this page right here. This was that other link that I showed you. Visualizations, and they got a bunch of them here that you can check out, but it's this first one right here that I clicked on. If you click on this file right here, MP4, 1080p, and this shows a 3D ball with the dynamic clouds mapped onto it. Again, this is 100% CGI and admitted to be such. Pretty impressive, though, in terms of what CGI, what's going on here with CGI. There's actually quite a bit of interesting technology taking place here, represented here. All right, so this is CGI and admitted to be such. And if I put the two side by side again, yeah, I'm not seeing much of a difference. Actually, I think the coloring on the admitted CGI is actually better than the one that's allegedly real. It looks, the coloring of the continents and stuff look more realistic to me. And then we come to this one right here. This is from August 5th, 2015. From 1 million miles away, NASA camera shows moon crossing face of the Earth. This is, I guess, the EPIC camera or something like that, Discover satellite. So I downloaded that video, and I have it here in my video software. And I call this the Bozo Earth because that's exactly what it looks like some kind of bozo clown, especially like freeze framer right here. So you got like an eyeball here with a long eyebrow, bozo nose, and sad frown face. There's a lot wrong with this picture. I know a lot of people have covered this in the past, but what you can see right here is the edge of the camera lens, I guess. So it's sort of like got what I would imagine something around the equivalent of a looking through a toilet paper tube or something as far as field of view goes. Again, there's no cloud movement. There's no perception of any clouds moving here. I don't see any movement in any clouds. They're just rotating with the Earth. I don't see clouds changing shape. Now this is a CGI representation of the satellite, as they always are CGI. We never actually see a satellite. We just see artist renditions of the satellite staring at the Earth. Now, this is a million miles away in what they call, I think it's Lagrange or something like that, L1. How the heck is this satellite sitting there, stationary, looking through a toilet paper tube, looking at the Earth, keeping it perfectly in the frame with the solar system doing this? Again, I don't get that. How is that happening? How is this thing compensating for all of the motion that is supposedly taking place with our solar system trailing along the sun in a vortex through the Milky Way galaxy? How does that make sense to anybody? Second of all, we're told that there's this thing out there called the Van Allen radiation belt, and that supposedly protects the Earth from harmful radiation blasts coming from the sun. You see pictures like this: solar wind, bow shockwave, Van Allen radiation belt. So, we supposedly have this blast of solar wind radiation slamming into the Earth, causing some kind of configuration like this in terms of how all that wraps around the Earth, as the Earth is supposedly protected by the Van Allen radiation belts that go out to 25,000 miles. So this satellite is right in the middle of the blast wave, where it has to be unimaginably hot, for one thing, blasted by radiation. Last time I checked, radiation wreaks havoc with computers and pretty much anything. So how is this satellite just sitting there in all that solar wind as the sun's moving through the galaxy at over 500,000 miles per hour in this vortex path, looking through a toilet paper tube field of view and keeping a nice, clean, steady shot of the Earth like this? I don't know how that's possible, but here we have the Earth again with no clouds moving, and here we have a moon popping in, photobombing us. Now, this moon would be, a lot closer to the satellite, and it should be way brighter. This camera should register if it has any kind of an iris in it, unless it's just a fixed iris. Well, if it's a fixed iris, then this thing should be blown out. This should be very bright. It should be a lot brighter. It should probably look something like this. And if it has an iris, it should adjust. There should be some kind of dimming of the Earth behind it to keep this kind of exposure. So I don't see any evidence of what should happen with a camera when something brighter comes into the frame in the foreground. The other problem is when you look at this moon, it has some very bizarre shadowing on this one side right here, and when you zoom in on it, it's got like a green edge, like it's like a mask or something. And there's no three-dimensionality to this. It looks like it's just something moving across the screen that is two-dimensional. See the shadow on the right side? It never changes going all the way across. You would think that due to the angles, if it's a 3D object and this is an actual photograph of the moon going by, then the lighting should change, the exposure should change, the shadows should change, but none of that changes because we've been punked by a bozo. So now let's compare the Galileo 1990 with the 2011 space probe on the right, the complete CGI in the bottom left, and the 2015 bozo Earth. The top left and the bottom right, none of the clouds appear to be moving in any way, shape, or form. Of course, the CGI shows the clouds moving on the lower left, and what I'm going to say is CGI, allegedly from a 2011 space probe, the clouds are moving. So What's the deal? Why can't they get it right? Well, because we're dealing with different time periods and we're dealing with different levels of sophistication in CGI technology. And so this, among many, many other observations, analyzing video footage and still imagery from NASA, JPL, and other websites, it just doesn't add up. There's too many things wrong with it, too many strange anomalies, too many inconsistencies, clouds moving sometimes, clouds not moving other times, never seeing any stars. So that was a huge part of starting my journey into testing what I think I believe about the Earth and its place in the cosmos.
I wanted to take the time to really show all of that, because one of the number one proofs that you always hear people say when you ask them, well, why do you believe the Earth is a globe? They'll say the photographic evidence. Well, clearly there's something seriously jacked up with the photographic evidence, the video evidence. When you look at pictures like this, and then all of a sudden every year, the United States grows bigger, it shrinks, and the colors change, everything's, if photographic evidence is your number one reason, then you don't really have a very good number one reason, do you? When you start looking at that stuff. But then you'll have all these videos coming out, and I've noticed more of them coming out recently. Have you guys noticed like an uptick in the last 6 to 8 months or so of all these videos? Why, we know the Earth's a globe, trying to squash this rapidly growing movement. But I'm like, really? Is this the best you've got?
The Earth is round, and here's the proof. Remember Felix Baumgartner? He jumped from the edge of space a few years back to perform the highest parachute jump ever. Well, that was on a live feed in front of hundreds of thousands of people, and you can clearly see the Earth's curvature. So yes, there is tons of proof that Earth is a sphere.
Yes. Yeah.
Funny how the same curvature was visible at 5 feet before he touched the ground. This is your proof? Really? I mean, how many people have you guys had that go, see a curve? You're an idiot, stupid, see a curve. That's the voice I hear in my head. Like when people do stuff like, just complete the curve. Yeah, when it was straight. If you see something like that, and all you have to do is complete the curve to realize how absurd that is. That's planet New Mexico. Right there. And otherwise intelligent people were sending me stuff like that. And I was having arguments with these people. And Mythbusters, right? They sent a spy plane or whatever up to 80,000 feet or something. And, they were sending me all these clips. Why can't you tell? This is real. I'm like, duh, look the curve. They're saying this is the curvature of the Earth at 70,000 feet. Funny, the same curve is right behind his head at about 50 to 100 feet off the runway. My friend's like, why can't you accept what's plainly and painfully obvious? I'm like, yeah, exactly. See the straight line behind his head? Perfectly obvious, right? And you have all these websites that were coming out with all these students, right? Students film breathtaking curvature of the Earth using high-altitude weather balloon. These are like university students. You would have thought that the curved rope might have given them a clue. Man, maybe something's off. But why did they get excited when they were at 50 feet? Woo! University students prove curvature of the Earth. 50 feet. 4 seconds in. But, how many of you have received this from your friends and family, sending you this kind of stuff? I get this all the time. People say I'm doing this to get rich and famous. I'm like, first of all, you'd have to be a serious moron to even entertain that thought. But I wish I had a dime for every time some moron sent me stuff like this as their proof. Right? Because then I would be doing pretty well. I had lots of people come to me and say, if you've ever been in a plane, you see the curve of the Earth. Well, I fly all the time. I'm like traveling the world, like I'm in planes like every month almost. And you bring these go take pictures without using a fisheye lens. Take pictures of what's out your window, bring it home, put it in Photoshop or something like that. Put a parallel line over it, you're going to see it's flat. There was a flight I took when I went to Amsterdam a while back. D. Marble did the spirit level test, and that was sort of his claim to fame on that.
I actually did the experiment before he did, several months before. In fact, the previous year, 2016, I put out the challenge after watching the Max Egan video that Jeranism did. At the end of it, I said, whatever assumption you start with, you have to admit it is very interesting that the on-screen display says that they are on a northwest heading, which is what you would expect if you just flew up from under the ball, headed towards Sydney. Yet Max Egan has this compass sitting on his tray showing a heading of southwest. Things that make you go, I'm very intrigued by this. If there's anybody out there who can make this flight and document it, I'd like you to do two things. Confirm what Max Egan did by bringing a compass with you on the flight. Do the same thing he did. Bring a compass with you. Please use a better camera so you can actually hear what's going on and it's not so herky-jerky. Use your iPhone or something like that. So document it as best you can. And I would say also bring a spirit level with you. I'm not going to get into it in this video right here, but that would determine whether or not you are flying straight and level. Now, of course, I know that you will be flying straight and level because that's what pilots do. But that's not possible on a ball. You cannot use your attitude indicator set to level and fly 500 plus miles an hour over a ball without significantly increasing in altitude about every 12 minutes. This is because at 500 miles per hour, every 12 minutes or so, you'd be going about 100 miles. In fact, according to the Pythagorean formula for calculating curvature, in 1 hour's time, this is how much altitude you should accumulate if flying straight and level. Unless you be tempted to say attitude indicators don't work that way and that they do, in fact, adjust for the curvature using that magical Tony the Tiger force of gravity. See the description below for a couple of videos that debunk that idea. Anyway, here's my challenge to anyone willing to take me up on it. Bring a compass, a good camera, and a spirit level, and if somebody out there can make this flight and document it, do what Max Egan did, send me the video. I'd love to see it. That would be something really cool to check out.
So, taking on his cue, I brought my compass on this flight. And I brought my there's a digital compass on the phone that also has a digital level, and I brought a spirit level. Things didn't happen that should be happening.
Okay, so here you see my spirit level, and here you see both my phone and my wife's phone. We have the compass app that also has a level on it, and as I was tilting it right there, you can see how it works. It shows negative, up or down if it's tilting forward or backwards. Got my compass out here, put it next to the two phones that I had right here. I'm using both phones to kind of double check with two sources. I decided not to have my level nearby because it has a magnet on it and it could be causing a problem for the compass, so I stashed that away in my luggage so it's not going to cause a problem. And so I recorded it actually separately. What you see in the top left corner here is a video I shot of about 15 minutes worth of just the spirit level. I got rid of everything else, so it's just the spirit level sitting on my tray table. And I recorded that for 15 minutes. And then separately, the video below that here is with the two iPhones and the level app on those phones with my compass. And I recorded that for about 15 minutes. So other than some minor turbulence here and there causing it to switch to about -1, I think was the most I saw as far as it changing its level, they both stayed in the green at 0. So, I mean, here's two tests I did. One with just a spirit level for 15 minutes, and one with two iPhones using the same app, just to make sure both of them are working right. Every now and then I had to tap my phone and my wife's phone because it wanted to go into sleep mode. But otherwise, there you have it. So at no time did the plane ever show any indication of going into a nosedive as you would expect that it needs to when you're flying over a ball. And I know there's people going to argue against that. And that's, I'll make another video that deals with that issue. Oh, gravity is taking care of the whole situation. No, it's not. You don't understand how a gyroscope works. But again, that's a whole other video. Right here, you see the on-screen display showing our speed, showing the path we're taking. In the top right, I've got a freeze frame of that. You show the circle of the Earth navigation from Minneapolis to Amsterdam, which on the flat Earth map is a straight line. So there you go. And again, I'm just kind of going back and forth with my camera, just kind of showing. It's tapping the phone again because it's want to go into sleep mode. The compass gave pretty much an accurate reading the whole way, as I expected it would in the northern hemisphere. I expected it to show an accurate representation of our flight path, both on the circle of the Earth navigation as well as the straight line on the circle of the Earth. So that's no surprise to me. The Max Egan one isn't really a surprise either if you subscribe to the circular flat Earth model. His reading's exactly what you would expect it to be, but not what you would expect it to be if you're looking at the on-screen display in the circle of the Earth navigation. So that's why I wanted to show that clip before this one. Again, there's a lot more to talk about. I don't have the time to do it with this video right here. I just wanted to get out because a lot of people were asking me what happened. People saw the picture that I posted on Facebook saying, hey, I'm all set, ready to go on my flight. I got my compass, my level, and ready to do some tests on the flight. And so since people have been asking me over and over and over again, what were the results? What were the results? I decided just to put this video together. Maybe at some time in the future I'll do another video that will explain the issues of the avionics, the attitude indicator, the altimeter, the airspeed indicator, and how a gyro works, and show that the whole idea that gravity is keeping the plane level is utterly ridiculous. We should be having to dive down. Actually, we're going faster than 500 miles an hour. The calculation I had where it said that we should have to either take a nosedive every 12 minutes to 1.26 miles or show an increase in altitude of 1.26 miles, or what is that, about 6,653 feet every 12 minutes. Now again, that calculation is based on going 500 miles per hour, but as you'll see on the on-screen display, we were going closer to 600 miles an hour, so we would have that problem in less than 12 minutes. I'm not going to do the math out here. Somebody else can do that if you feel so inclined, but at any rate, as I monitored the altitude, I never saw much more than a very minor fluctuation, maybe 5 or 10 feet or something like that, which could be accounted for with updrafts and turbulence and things of that nature. So never saw a dramatic increase of altitude, which you should see if you're flying straight and level, and all of the instruments that I had were showing that we are flying straight and level. I'm sure in the cockpit the attitude indicator was showing that too, because that's how a pilot flies. He's always monitoring. I mean, he's got lots of instruments to monitor as well as radios and stuff like that, but 3 instruments that you're really paying a lot of attention to when you're flying is the airspeed indicator, the attitude indicator, and the altimeter. And they really work together, because if you're all of a sudden noticing that you're increasing in airspeed, there's a pretty good chance you're probably in a dive. If you're decreasing in airspeed, there's a pretty good chance that you're in a climb. And or if you're looking at the attitude indicator and you're seeing, well, I'm in a climb or I'm in a dive, you'll notice that in your airspeed indicator as well as in your altimeter. So these instruments would be in conflict with each other if you're flying over a ball. If you are focused on keeping your airspeed the same and keeping your attitude the same, i.e. keeping the horizon perfectly level, in both to your eyes if you're able to see the horizon out the window, as well as to the attitude indicator itself. If you're keeping that plane straight and level, flying straight and level and maintaining airspeed, then your altimeter, if you're flying over a ball, must show an increase in altitude. And I'm sorry, gravity's not going to save you. So anyway, I'll just go ahead and let this play the rest of the way. I recorded for about 15 minutes twice, again, once for just the spirit level, and again with the 2 iPhones and my compass. And I took both tests, put them here on the screen for you to watch both tests at the same time. And, well, you'll see. We'll just let it play out for 15 minutes, and you'll see that there was no change whatsoever. Brought a compass, a spirit level, and I used the compass app and the level app in the my wife's iPhone and my iPhone. So I had like double and triple check tests going on at the same time. Had a nice long flight to do it on too. And yes, it is true that pilots fly the Great Circle navigation. The Great Circle, yes. Because what it does is it creates an artificial equator, because the shortest distance between 2 points is a straight line. So that's forcing a straight line, bisecting the ball into 2 hemispheres, basically. But what's interesting is, like when I did the flight to Amsterdam, this was the path that I took. Okay. And we're going over to Amsterdam. We're going to go up over Greenland like this. Interesting thing, on the circle of the Earth, it's a straight line. Kind of cool. So yeah, but I mean, this is the other problem, is if you're flying in a commercial airliner at 500 miles per hour, you'll be flying at about 8.33 miles per minute. 8.33 times 60 minutes equals 499.8 miles in an hour. Thus, at 8.33 miles per minute and times 12 minutes, you will travel 99.96 miles. So, for example, rounding up to 100 miles, in the first 12 minutes, the expected curvature below you is 1.26 miles. And it just keeps getting exponentially higher and higher as you go. So, if you have an attitude indicator, which tells you if you're turning left or right or diving or climbing, and you have an airspeed indicator and an altimeter, 3 very important instruments that pilots are always scanning. And if you got your plane trimmed for level flight, and the gyro is spun up inside and the airframe is caged to the gyro, the function of the gyro is to maintain rigidity in space apart from gravity. If it was dependent on gravity, stunt pilots could never do what they do. Pulling the G's and doing all this, they can never rely on their instruments, because all their instruments would be completely jacked up due to gravity. The function of the gyro is to maintain rigidity in space apart from gravity. So if you've got your airframe caged to the attitude indicator gyro on the flight line at level, then when you're flying and you trim your flaps and everything, your controls, for straight level flight, and your attitude indicator shows that it's right across the horizon, is going right across the center of the gauge. You're not climbing, you're not diving, you're not turning left or right. It's level, and you're maintaining a constant speed. If you keep your airspeed at 500 and your attitude indicator straight and level, then your altimeter must begin to register 1.26 miles in the first 12 minutes, and it keeps going higher and higher and higher from there. 60 in 36 minutes, 60,086 feet. You should be above the ground, and eventually you just shoot out in space. And people try to use the argument, well, there's like a gravity holding on to the bottom of the plane, and it's like tied to a rope, and it's maintaining level. Sorry, that doesn't work with the gyro.
The following is taken from the most recent edition of the Federal Aviation Administration's publication, The Pilot's Handbook of Aeronautical Knowledge, Chapter 7, page 15. There are 2 fundamental properties of gyroscopic action: rigidity, in space, and precession. Rigidity in space means the gyroscope remains fixed in the plane in which it is spinning. Thus, if the gimbal rings are tilted, twisted, or otherwise moved, the gyro remains in the original plane. Rigid, in space. Let's watch a few gyros in action. Up first is a video produced by the United States Navy in 1960, used to train pilots on the mechanics of their flight instruments.
To understand any gyroscopic instrument, you must understand the principle of the gyroscope. It consists of a rotor mounted in a gimbal. The rotor can spin in one plane only. When another gimbal is added, a second plane of movement is possible. And when this assembly is mounted in bearings, the rotor has 3 planes of movement and can assume any possible attitude. This is now a freely mounted gyroscope. A spinning gyro has 2 important properties: precession and rigidity in space. All of its practical applications are based on these 2 properties. As for rigidity in space, the spinning rotor remains in its original attitude, while the gimbals and base move around it. In other words, the gyro maintains its axis in relation to space and not to the surface of the Earth. If a gyro moves around the Earth, its axis is vertical to the Earth's surface here, at an angle here, and horizontal here.
The spinning wheel prefers to stay oriented as it is, and it resists any attempt to change that orientation. The fact that gyroscopes will maintain a particular orientation in space is very useful. In modern aircraft, an inertial guidance system uses spinning gyroscopes to monitor and control the orientation of the aircraft. The gyroscope is suspended in a special cage that allows it to maintain its orientation independent of the aircraft's position.
An attitude indicator, also known as an artificial horizon, is an instrument used in an aircraft to inform the pilot of the orientation of the aircraft relative to Earth's horizon. It indicates pitch, fore and aft tilt, bank, side-to-side tilt, and is a primary instrument for flight in instrument meteorological conditions. Pilots must rely on this instrument in order to maintain control of the aircraft during flight in IMC.
Each instrument continuously indicates the roll and pitch attitude of the aircraft in relation to the actual horizon, and each obtains this information from a freely mounted gyro. The axis of the rotor is vertical and, due to the property of rigidity, will remain in this position as the aircraft assumes any attitude. Therefore, the gyro establishes a vertical reference from which roll and pitch deviations of the aircraft can be measured.
Another excerpt from the pilot handbook states, "The gyro is mounted in a horizontal plane and depends upon rigidity in space for its operation. The aircraft actually rotates around the spinning gyro." Now that we have a fundamental understanding of how the gyroscope and attitude indicator works, let's contemplate an intriguing and quite contradictory scenario. A scenario that occurs every single day during every single flight. When an aircraft takes off, climbs to its final altitude and levels off, the attitude indicator depicts a perfectly level attitude. As the aircraft travels towards its destination, sometimes in excess of 7,000 to 8,000 miles, the aircraft's attitude indicator maintains a perfectly level attitude. This, as we have seen, cannot be correct, because the gyro maintains its original position in space, regardless of the aircraft's attitude, or its position on the Earth. According to known gyroscopic properties, a pilot flying by reference to his attitude indicator should in reality begin to fly away from the Earth, as the gyro will continually give a straight line from the plane in which the aircraft started. Again, it is stated that the attitude indicator is reliable and the most realistic flight instrument. It gives an instantaneous indication of even the smallest changes in attitude, and, since the gyro relies on rigidity in space, the aircraft actually rotates around the spinning gyro. Therefore, we can logically only conclude 2 answers to our problem. Either A, the gyroscope operates on a set of properties unknown to modern physics, in which case, many aircraft must be susceptible to potential errors from an instrument we truly do not understand. Or B, our world is not what we have been told. The curvature of the Earth is not what is claimed by NASA. nor is it curved much at all, lest the gyroscope would read inaccurately during every flight. One can only conclude that the gyroscopic properties are fundamentally true, and therefore the world in which we live has a few more questions that need answering.
Gyro's job is to maintain rigidity in space apart from gravity, independent of gravity. I mean, if gyros are subject to the same forces that humans are, well, when you talk about G-forces, you're pretty much screwed. if the gyro is reacting to gravity like this, it's not a very reliable instrument. And perhaps that's why NASA has, I mean, you could go to NASA websites and see for yourself where they have documents like this right here. You click on that, it takes you to a PDF. It's of a document called The Derivation and Definition of a Linear Aircraft Model. NASA reference publication 1207, published in 1988. You can scroll down to the opening statements. Summary. This report documents the derivation and definition of a linear aircraft model for a rigid aircraft of constant mass flying over a flat, non-rotating Earth. The derivation makes no assumptions of reference trajectory or vehicle symmetry. The linear system equations are derived and evaluated along a general trajectory and include both aircraft dynamics and observation variables. And you can scroll through this document, and most of this is aviation mathematics and things of that nature. A lot of math going on here. And scroll down to page 30, concluding remarks. This report derives and defines a set of linearized system matrices for a rigid aircraft of constant mass flying in a stationary atmosphere. In other words, the atmosphere is not being velcroed to the Earth, traveling 1,000 miles an hour, over a flat, non-rotating Earth. So they're saying it again in the concluding remarks. And you can find another document that's similar to that one at the FAA.gov website. You can probably read this long URL here if you're interested. And you can scroll down to page 32. Somewhere thereabouts. Yeah. The observant reader will notice that the aircraft equations of motion were calculated assuming a flat Earth, and that we here assume the development frame was the northeast down frame. This implies necessarily that Earth rotation and the variation of gravity vector with position over the Earth were ignored in developing the aircraft equations of motion. Okay, we're talking about high-performance aircraft traveling at or below Mach 3. And yet all of their equations are based on a non-rotating flat Earth? And someone will say, well, that just simplifies the math. Well, it also could just be that you can't fly the way they say you're going to fly if you're flying over a ball. I mean, this is the FAA and NASA saying that they create their aircraft performance analysis based on a non-rotating flat Earth. Go figure. And this is perhaps because of all the reasons that I've been talking about here so far. So D. Marble did his spirit level test. I did my spirit level tests. I'm sure there's probably others out there that did spirit level tests as well. And I found this video here by Paul on the Plane where he's talking about a fairly recent test he did back in September 2017 or August using a bubble level app on his phone. I guess this is, I think, the second or third time he's done it, actually. Check this out.
So today's video is a little experiment I conducted last month while traveling on business. I was back in Lake Tahoe. Many of you may remember the 18-mile convex water experiment on Lake Tahoe. I think it was last March, from which I drew the conclusion that either the Earth is much larger than we've been told, or it's generally flat. No, I didn't find any water curving over the 18 miles, even though the pictures of Tahoe we get from quote-unquote space that we are given show major curvature. So there's two casinos on the South Shore that stand about 200 feet high, and I was able to see them from 18 miles away with my Nikon P900. So yeah, do the math. I shouldn't have been able to see them. But I digress. Okay, so this experiment is another bubble level app experiment. And yep, I'm the guy who flew from Seattle to Ireland last June to test the alleged curvature with the bubble level app and found that there was no curvature. We flew over a flat fixed Earth many thousands of miles. I also did a video driving about 200 miles to measure curvature with the app, and of course, failed to find any. It's funny how everyone who goes out attempting to measure curvature is unable to. Huh. Crazy, eh? Okay, but back to the Bubble Level app on our smartphones. It's funny how many people still think that the Bubble Level app, which unlike a traditional bubble level can be locked at any orientation, at any angle or degree, and that they think it would not show a change in the bubble, especially over so many miles. They simply don't get how the technology works, I guess. We should be able to lock the orientation of the phone in free space with the Bubble Level app and slowly see the bubble move off center over a period of even 30 to 60 minutes as the alleged spin of the Earth happens. You globe defenders do get that, right? I mean, the phone is locked into a certain orientation in free space, so any movement of the phone will register a change in the bubble. Any movement of the phone's angle will register a change in the bubble. Think about that some more. Okay, so many people have even proven that the phones are sensitive enough to measure the Earth's spin, but it's funny how the spin never is registered. Okay, I digress. Again. So I got a lot of feedback on my Seattle to Ireland video that since I was flying west to east and the Earth allegedly rotates east to west, that I simply flew, quote-unquote, into the spin and stayed relatively on the same latitude, even though I flew a lot farther north, that the Bubble Level app didn't register a change because I was relatively in the same position as when I left Seattle some 15 hours earlier. Kind of a stretch, but it seemed to be a common theme that I was getting. Even the awesome Jaren from Jarenism on Globebusters, on a Globebusters episode a week or so later, commented that he'd like to see the same experiment done on a trip north to south or south to north, so that argument could not be used. Well, that's the experiment that I conducted here. I was flying from Reno, Nevada to Seattle, Washington, which is clearly a south to north route, as you can see here on the map. So there's no chance that I flew into the alleged spin or could be in the same relative position after the 2.5-hour flight between the two airports. Okay, so here was my results. I took a screenshot of the Bubble Level app sitting on the plane in Reno, and you can see the time date stamp here, and the other screenshots I took showing the altitude and the latitude and longitude from the two apps to confirm my position on this flat, fixed plane that we live. So these coordinates will show you that I was here when I took the first measurements. And then a few hours later, when I landed in Seattle, I did the same thing. I took a screenshot of the Bubble Level app, and as you can see, no change. It should have been off by at least a few degrees. I mean, considering I flew approximately 563 miles, and Seattle should be about, 211,000 feet or so below the horizon, or about 40 miles, when I'm sitting in Reno. Yeah, I should see a few degrees there, guys. And here were my coordinates sitting on the runway in Seattle after landing, where I took the second and final measurement. So, there you have it. My first two experiments were west to east and east to west, so here is an experiment traveling the alleged globe south to north. But, unfortunately for you globe defenders, that darned elusive curvature was not found again. When is someone going to be able to measure that darn thing, huh?
And that's the real issue, isn't it? There was a video going around a while back with this guy that had an interesting accent. Where's the curvature? If you can't measure curvature, then maybe there isn't one to be measured. There are a lot of people out there, just regular people, getting in boats and using lasers and going out and doing tests for themselves.
Which is interesting. Some of you may have heard about the so-called polar navigation thing that's coming up in October, I think it is. I'm not sure exactly when it is, but they're planning on circumnavigating supposedly the Earth pole to pole, but they won't allow you to bring any scientific instrumentation on the plane.
It's going to be a one-time historic flight. And we've got different languages. Let's just scroll to the bottom here. Let's get into the fine print. So this is what was brought to my attention. And I think it's really troublesome when it comes into a flight. What would they be trying to hide? Let's go through here. Cancellation, charter flight price. All right, responsibility. All right, what do we got here? Code of conduct. Polar Explorer is a celebration of commercial aviation and as a homage to the achievements of Pan American Airways. The spirit of this flight is one of adventure, friendship, and the shared goal of establishing new aviation speed records. Although the flight is open to all who wish to join in, it has come to our attention that some have expressed interest in using this flight to attempt to disprove or discredit scientific fact. As the safety and comfort of all our passengers is our primary concern, we will not permit any scientific or experimental equipment of any kind on board the aircraft. All right, so there you have it right there. Now, this basically, I think, was added in just recently because it came to my attention as well that there were a couple of flat earthers that were actually signing up to the flight. And their plan was to bring gyroscopes and levels and all sorts of different equipment. And they thought this is a great opportunity. We can basically pay for the flight, we can bring our equipment on, and we can confirm this once and for all. But what does Pan American Airways have to say? No, we are not going to allow any type of equipment whatsoever. And now this stuff is not against FAA regulations. This stuff, would not be completely deemed wrong in any type of security. But yet they're going to basically ban any type of scientific experimentation on the plane. Any type of tools like a gyroscope, like a spirit level, like Daryl Marble did. This is crazy.
Interesting. Why couldn't I bring a compass or a few things with me? Really? Why? There's no reason for that. So, these are some of the things you start going, what? Wait a minute, something's up here. Meanwhile, your friends are going, oh, if you've ever been to the beach, you've seen the curb. Well, I've been to a beach a few times, so I go out to Malibu and I'm taking pictures of the horizon, right? And it's straight and level, and I said, well, maybe, so I went up into the mountains. Maybe I could get a little higher. So I went up into the mountains above Pepperdine University. I'm looking out. That's about 100 miles across right there. Take a picture, put a parallel line over it, straight. So then I meet with this guy who's a writer who's helping me out with my seed project, script writer. And we go out to eat and he's following some of my work and we start talking. And he tells me about this place called the Anacapa Arch that you can see from Ventura Beach. Now, it's almost 20 miles away. Now, when you do the curvature math on that, you shouldn't be able to see this. This arch is only about 40 feet off of the water, the top part of the arch. He's like, but we've all seen it. So he said, I got to tell you a story. He said, I went to a math professor, a friend of mine at the university nearby, and he said, we're on a globe, right? Yeah, what's the math? Well, he did the math, and it's 8 inches per mile squared. So he says, how far below the horizon should something be that's 40 feet tall and about 20 miles away? The guy did the math, told him, and however high it was. So he said, so you're telling me we should never be able to see that? No, it was like 100-something feet or whatever below the curvature. I forget what it was. He said, well, the problem is we've all seen it. And the professor says, what do you mean? He goes, the Anacapa Arch. All of a sudden you hear that Flintstone sound effect. Remember that? That sound effect that they would play like when somebody blew Fred's mind or something. Because here's this math professor that just did the math and said that's impossible, yet they grew up in the area and everybody's seen the Anacapa Arch. So I eventually went out and got myself the Nikon Coolpix P900 camera, which they should have commercials out now, bringing ships back over the horizon since 2015. Because flat earthers are the ones buying this thing up. In fact, I went to a superstore and just to see if they had it, and the guy that was running that department, he says, no, we can't keep these things in stock. I don't know why. I said, I know why. He says, why? What do you mean? I said, do you know what cognitive dissonance is? No. So I told him about that. I said, would you like me to continue? Yeah, I told him flat earthers are buying them up. He's like, what? I said, cognitive dissonance. I said, when you get one in, go to Lake Louisville, which is a big reservoir near that superstore, and it's 7 miles across. I said, you're going to see stuff you're not supposed to see. And this picture right here, this was taken down in Florida. My parents are snowbirds. They live in Massachusetts and fly down to Florida for the winter. So we went out to eat, and there were these fishing boats going out at sunset. And there were these mile markers that the ships were following this path. And they're going out like 4 miles. Well, it's a 15-foot tall ship, and going out 4 miles, 10 feet of that ship should be missing. So I get my camera down, real down nice and low, and I shot that picture right there. And my dad was there with me, and I said, he's been aware of what I'm talking about. And I said, hey, Dad, come here. Check this out. And I said, that's 4 miles out. Yeah, and we did the math. I said, look at this. He comes over, he looks in the viewfinder, looks at me, and just walked away. Like, I'm 75, I don't care, you know. But that's the kind of stuff, I mean, you have to reckon with this stuff, right? There's a video came out recently that Taboo Conspiracy, he's been putting out some really great stuff, put out a video from another YouTuber named Jay Tolan Media One. This is observing something 53 miles away.
We're going to begin with coordinates of Jay Tolan Media One's camera. Here was his location. His camera was at an observation height of roughly 150 feet. You can see the same on Google Earth. This ruler line indicates the path from the camera in Malibu to Catalina Island. From the photographer's point of view, he was observing the utmost left part of the island, which would be the actual southeast corner of Catalina Island. As you can see, the distance to the far left of the island, from his point of view, was roughly 53.3 miles away. Plug in the numbers in a Earth curvature calculator, and you get a target hidden height of 978 feet based on official dimensions of the alleged ball. However, this little step formation only has an approximate elevation of 200 feet. According to the official dimensions of the globe, this area of Catalina Island should be well hidden by a target hidden height of 978 feet with more than 700 feet to spare. In addition, these far distant boats that are maybe 40 miles away should likewise not be visible. I created a pathway tour on Google Earth so you can see that I'm not trying to trick you. The observations from Jay Tolan Media One's video and Google Earth match almost perfectly. And just to reiterate, this little formation should be hidden more than 700 feet below the horizon. This ferry and its escort should not be visible in any manner. It is time to accept the fact that there is a flat Earth optical phenomenon that is real, observable, and repeatable. This is not a mirage. This is a direct line of sight that defies the globe model and should cause any objective thinking person to question his globe conditioning.
Yep. Go out and get that camera. You're going to start seeing things you're not supposed to see. Now, I don't know what camera that other guy was using, but the infrared filter was a good idea. In fact, I had a similar idea when this picture came out, and I first saw it and had the conversations with Rick about it, which incidentally was about the same distances as I recall. It was about 53 miles, same distance as that other guy's observation. And I was like, if it's miraging and it's all this kind of stuff that our eyes are having problems with, I wonder what infrared would do. So, we had some early conversations about that, never got around to doing it, but it was cool to see that this other guy is doing it. And apparently he's been pumping out some pretty good videos on that recently. So, of course, we see this picture, and you guys are probably familiar by now with the weatherman saying that's a mirage, right? And after talking with Rick about it, I became obsessed with, we have got to do this test. And it took us a better part of a year to get it planned and to raise the money for it and to have the right timing as far as the safety factors and booking a charter and all that stuff. But we went out there and we did our test and proved that it was not a mirage. Now, I wasn't going out there to prove that the Earth was flat. I was specifically going out there to prove that it was not a mirage, because our thinking was if it's a mirage, then it's going to magically disappear and then the city will roll up over the ball and, or if it's just the city that we're actually seeing, it's just going to get bigger and bigger and bigger in our camera, and that's what it did. So we proved that. Now, to be fair, we were like, it'd be really cool if we had some really good evidence that would prove that it's flat too. Of course, I don't remember going over this massive bulge in the middle of the lake there. But there were a number of observations that we made there that it took a while. I had to sit there and simmer a little bit. I had to think about it for a while. Why were we seeing the things that we were seeing? Why was the bottom of the city missing? Is curvature the only answer for that? And I came to the conclusion that no, it's not the only answer for that. We're going to play a video again here. So, dealing with some of the observations that we had out there that led to my conclusions about atmospheric lensing.
There is a lot of water in our atmosphere. But I'm thinking if the atmosphere, especially over water, is made up of zillions and zillions of tiny convex drops of water, then collectively perhaps they all combine to make one big convex lens, in which case it would act like a magnifying glass. Okay, so with that in mind, let's look up some websites dealing with the refraction of light. You might see a graphic, something like this, showing light bending downward, just like the weatherman guy said. And here's your typical graphic showing how light rays entering some sort of medium, like in this case water, refraction causes the light to bend downward. Now we've all seen pictures of, a pencil or something in a glass of water, and how not only does refraction bend the image downward, it also magnifies it. I'm going to say that again. Water causes refraction, bending the image downward, and magnifies it. So this is important now. And let's just go back and hear from the experts once again what's happening with the atmosphere.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
Again, based on that imagery that I saw looking 46 miles across versus 0.6 miles across, I really do believe that, just like the expert said, the globalist guys, these are people who believe in the globe now. They are the ones that said, hey, the atmosphere really is acting like a lens, and they put a lens in front of the camera to show how it works. So I'm just doing what they're doing. I went on Amazon and I got these plastic magnifying sheets, and came up with another way of doing the same thing, using the sheet right here. Set the city up, a little cutout of the city, and now I've got the big magnifying glass sheet. Bring the camera right up to the lens. See, that's the normal view of the city. Now let's back up again.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here,
the atmosphere really is acting like a lens.
Yes.
Atmosphere really is acting like a lens, and this is how much of the city is missing due to the lensing effect, the magnification of the atmosphere. So thinking about all this, and thinking about what I had just shown you regarding atmospheric lensing, magnification, refraction, all that with regard to cities and objects at a distance on the land, I got to thinking, I wonder how this would work with the sun and moon. So this is what I came up with. I've got my magnifying sheet frame, and I created a little stand to paste the sun on it and keep it the same height over the flat surface of a table. So the sun is always going to be parallel with the surface. And check this out. All right, here's the first test of a sun moving over a flat surface, and with no atmospheric magnification, it does what we might expect it would. It gets smaller as it goes away from us. All right, now let's see what happens when we add in our atmospheric magnification. Again, water and refraction. Water causes magnification and refraction, right? So let's bring the sun back. Oh, check this out. Refraction bends the light downward. It made the sun set on a parallel surface. As it was moving parallel, the same height, the whole way over a flat surface, the refraction caused the sun to set. Not only that, well, let's bring in the beginning of that little test, and we see that it maintained pretty much the same size, too. Pretty close. And of course, that's because as it's moving away, the magnification is still taking place. And so even though the sun's further away than it was in the beginning of the test, the magnification basically preserved the same size, and the refraction made it set. Of course, again, depending on how much moisture is in the air, we could see that the sun doesn't appear to change in size at all as it goes down. We could see sometimes perhaps that it looks like it's getting bigger when it goes down. You ever see like a really big sunset or moonrise, moonset, where one of them looks really large on the horizon? Well, that could be because there's lots of moisture in the air causing that effect. Or when there's less moisture in the air, obviously you won't have as much magnification taking place, and so it looks smaller as it goes away. So it's all relative to the amount of moisture that's in the air. Now, I'm just going to put forward a crazy idea for you to think about. And that is, if Rob Skiba could figure this out, I'm just going to go out on a limb here. I think it's quite possible that the creator of the cosmos could have figured out the same thing and engineered our beautiful sunsets, thanks to all that water he placed in our atmosphere. Just something to think about.
Thank you. When this is kind of when you go down this path of research, you don't get much sleep. You spend a lot of time thinking about stuff. And this was one of those ideas that just kind of popped in my head because Rick and I saw a lot of miraging type things when we were out there. And looking at how much water's in the atmosphere, I'm like, man, and they're telling me it's working like a magnifying glass. So, when the idea comes up to do this, and I'm like, really, God, is it really this simple? Like $10 worth of arts and crafts, I don't know. It was kind of a beautiful moment where you just sit there and go, wow, okay, cool. Meanwhile, a friend of mine sends me this. There's an app you can get for your cell phone called Theodolite. You can download it for about $6. And it's a great tool that surveyors might use and stuff to help you find angles and whatnot. We need to get my screen back up. There we go. That you can check angles and things of that nature. And so he's a flat earther. He lives in Washington State, and his brother lives in Denver, and his brother's not. So they said, well, get this app. I want to try an experiment. At the same time, they knew that the moon was out. They said, let's go outside. And they're on their cell phone. At the same time, let's take a picture of the moon in the crosshairs of the Theodolite app. Okay, ready? 1, 2, 3, click. Both of them took a picture. The software figures out all the angles and all the data and everything like that. And so then he took it to calculator.net. It's a website for doing all kinds of math problems. And they wanted to figure out the triangulation. Because, if you know the distance between 2 points and you're looking at something else, you can triangulate to figure out how far away the other thing is. So they did that. And when they did it, it showed up that the moon was less than 300 miles away. Wait a minute, let's try it again. So they tried again. Every time they did it, they were coming up with similar results. So he called a buddy of his that lived in Houston, did the same thing, came up with similar results, took it to a university. It showed them the app. And what do you think of this app? Wow, this is a great tool. I can see people really, this is, good value. What do you think of the website, calculator.net? Oh, yeah, it's a great website. Everybody uses it. Yeah, well, the app that you just endorsed and the website that you just said is really good just showed us that the moon is less than 300 miles away. There must be something wrong here. Programming here. I don't know, but these are the kind of things, these are the kind of results people are, because how many of you have ever even thought to test these things? Hardly anybody before this came up, right? We all just read whatever they told us in school. We never looked into it, but all of a sudden, some guys start getting us to question these things, and we take the time to actually test what we believe, and these are the things that we're finding. And along similar lines, people ask, well, how does night and day work? And one of the top 10, the reasons why we know the Earth's a globe is we have time zones and 4 seasons, like as if that couldn't work in any other model. Well, yeah, they can. Those things can work in other models.
So very early on in my investigation, as you can see, May 26, 2015, I was trying to figure out how does the sun work over the flat Earth. And I came up with this model. Now, I stated right from the start that this was not meant to be to scale. This one's a little better. I still think the sun may be a little bit too big, but you see the sun going over the equator here at an altitude of approximately 3,000 miles, according to this scale right here. And a lot of people will say, well, what is the sun acting like a spotlight? No, it's not acting like a spotlight. And to prove that, I'll bring in a little 3D object here, and I'll bring in a little dome on top of it here to show you that this light is throwing off in all directions, up, down, all around. It's not a spotlight. So all the critics out there, you can stop saying that. It's not shining as a spotlight. It's what's known in 3D as a point light that has been adjusted with a limited light throw attenuation. Now, shortly after I did that video, I was trying to figure out how the 4 seasons work, and you can see that video right here on YouTube, how the 4 seasons work on the flat Earth model. And that one was really interesting. I actually discovered this quite by accident, really. This video came as a result of me trying to figure out on the globe, how does the 24-hour sun work? And so I used Stellarium, which is heliocentric globe-based software. And you can put your location of observation wherever you want. So I put it in Antarctica. I think it was in the Ross Ice Shelf area or somewhere like that, wherever you supposedly can see 24-hour sun. So I put my camera there, and then I pulled it. You can adjust the camera and the type of lens you use, and you can adjust it such that you could either look at each cardinal point, north, south, east, or west, or in the case of what I did, I pulled the camera into the Earth and used the fisheye lens setting so that I could see all 4 cardinal points at the same time. And then I just got rid of the ground plane and removed the stars. So the only thing I could see then is the sun and moon. And I set it to record for a whole year real fast and recorded that. And this software, heliocentric globe-based software, showed the sun and moon speeding up and slowing down as it was creating these circles. And I just thought, well, geez, I wonder what that would look like on the flat Earth map, on the AE map. So I just superimposed it on that, and then I just flipped it horizontally because I'm looking down instead of looking up. And it actually showed the sun and moon going between the tropics and slowing down when it gets in the northern so-called hemisphere and speeding up when it gets in the southern hemisphere. But of course, the critics look at this and they ask a reasonable question.
Does it change speeds? Because the circle's bigger out here in the wintertime going around the Tropic of Capricorn. So what is speeding the sun up and then slowing it back down? It was constantly changing directions and speeds with your model.
Yes, it was. Again, heliocentric globe-based software created that. And interestingly enough, I found a video online that a guy went apparently on the Tropic of Cancer at a certain time of the year, on the equator, and on the Tropic of Capricorn, and videotaped the moon going across the screen. Now, he had it at double speed, and I made it a lot faster just for the sake of this video, but sure enough, the moon was moving at different speeds across his lens. Fastest over the Tropic of Capricorn, medium over the equator, and slowest over the Tropic of Cancer. I'd be curious to see how the Globers explain this. But at least the moon here reflected exactly what Stellarium, heliocentric globe-based software, had depicted. And I can only assume if the moon's doing this, the sun must be doing the same thing, though I'm unaware of any tests that have been done in that regard.
How crazy is that? You know, when I saw heliocentric globe-based software making it do that, I didn't make it do that. I'm going, what? I don't know how that works on the globe, Copernican model, but it definitely seems to have evidence on the circle model.
Thanks so much for watching. I hope you enjoyed this video presentation. If you did, please subscribe to my YouTube channel, like the video, and share it on your favorite social media sites. There's a lot more to come, so stay tuned and we'll see you back next time.